Statistics is about getting information from data when that data includes randomness. For example, consider feeding birds at a bird feeder and wanting an estimate of the amount of birdseed that the birds are eating each day as a way of estimating how much birdseed might be needed over the next month. Here is some data that might be collected by weighing the bird feeder and recording the amount of birdseed removed by birds each day for 30 days. Here are three plots of that data. First, a number line plot, which is a plot of the data as dots on a number line, a plot called a scatter plot, which shows the data as points over time, and a line plot, which is similar to a scatter plot, but with the points connected by lines. From the number line plot, it's easy to see that the numbers are spread somewhat randomly between about 50 and about 360. The scatter plot and the line plot, in addition to showing the numbers in the data, also show the day associated with each number. So these plots can show trends or patterns in the data over time. These plots show, for example, that use of birdseed varies widely, but with no strong trend up or down over time. It is in principle possible to get the range of the data and see the same trends and patterns just by looking at the list of numbers, but it's usually easier to get this information by looking at plots. For some purposes, though, it's necessary to have numbers rather than plots. To estimate how much birdseed might be used over the next month, for example, it would be useful to have a number for the amount of birdseed that the birds are likely to use each day. The mean of the data, which is just the average of the numbers in the list, is one estimate of that amount, but there is so much day-to-day variation in the data that there will likely also be some variation in the mean from one 30-day period to the next. The maximum amount of birdseed consumed in one day, after all, is much bigger than the mean, and the minimum amount is much smaller than the mean. To be confident of having enough birdseed, it would be useful to have not only the mean, but also an estimate of the variation of the mean to know how high or how low the actual amount might turn out to be in some subsequent period of time. There are methods in statistics for finding all of those estimates. It is also common to collect more detailed data, which can raise additional questions. For example, these lists show birdseed amounts separated into the amount used in the morning and the amount used in the afternoon each day over the same 30-day period. And here's a line plot showing the data in these lists. The mean amount of birdseed used in the morning is bigger than the mean amount used in the afternoon, but there were many individual days when more birdseed was used in the afternoon, and there is so much day-to-day variation in the data that the difference in the means may be a consequence of that random variation rather than a genuine difference between mornings and afternoons. For this and many similar examples, there are statistical methods for distinguishing between random effects and genuine differences. The topics to be covered in this course can be organized broadly into descriptive statistics and inferential statistics. Descriptive statistics refers to methods for summarizing and visualizing data, typically with plots, such as number line plots or scatter plots, or with numbers such as the minimum or maximum or mean of the data. Inferential statistics is about methods of using data to make inferences about the system from which that data was collected, such as using 30 days of data from a bird feeder to come up with an expected range for the amount of bird seed to be used in other 30-day periods, or using that data to learn if the birds really do, at least on average, use more bird seed in the morning or in the afternoon. The first few sections in this course explore basic topics in descriptive statistics, and the remaining sections are primarily about inferential statistics.